presence or absence of a recirculating piping system and pump significantly impacts the definition of a tub, specifically whether it qualifies as a hydromassage tub. The core concept revolves around the intended function and design of the tub. A hydromassage tub, by definition, incorporates a specific set of components designed to circulate water for therapeutic massage purposes. These components are fundamentally the recirculating piping system, a pump, and the associated equipment necessary for their operation and control. Let's break down each component and understand their role. Firstly, the recirculating piping system. This system is a network of pipes that are strategically placed within the tub structure. Its primary function is to draw water from the tub, direct it to the pump, and then return the water back into the tub, often through jets or nozzles. The design and configuration of the piping system are crucial for effective water circulation and distribution, ensuring that the massage action is delivered to the targeted areas of the body. The materials used for the piping system must be compatible with water and any additives or chemicals used in the tub, resistant to corrosion, and capable of withstanding the pressure and temperature fluctuations associated with the tub's operation. Secondly, the pump. The pump is the heart of the hydromassage system. Its role is to generate the necessary water flow to create the massage effect. The pump draws water from the tub through the intake portion of the piping system and then propels it through the return portion, often at a higher pressure. The characteristics of the pump, such as its flow rate and pressure capacity, determine the intensity and effectiveness of the massage action. The pump must be appropriately sized for the tub's volume and the design of the piping system to ensure optimal performance. Factors to consider when selecting a pump include its energy efficiency, noise level, and durability. Thirdly, the associated equipment. This category encompasses all the additional components that are necessary for the proper functioning and control of the hydromassage system. This includes items such as jets or nozzles, which direct the flow of water onto the body, air induction systems, which introduce air into the water stream to enhance the massage effect, control panels or switches, which allow the user to adjust the pump speed, jet intensity, and other settings, heaters, which maintain the water at a comfortable temperature, filters, which remove debris and impurities from the water, and safety devices such as ground fault circuit interrupters, GFCIs, which protect against electrical shock. Now let's consider what happens when a recirculating piping system and pump are absent. Without these essential components, the tub cannot circulate water. The water simply sits stagnant, and there's no mechanism to create the massage effect that defines a hydromassage tub. Even if the tub has an air pump, which introduces air bubbles into the water, this does not compensate for the lack of water circulation. An air pump alone can create a bubbling or swirling effect, but it does not provide the directed, pressurized water flow that is characteristic of a hydromassage. The air pump enhances the bubbling action, but doesn't provide the necessary water flow for the massage effect. So in summary, the presence of a recirculating piping system and pump are fundamental requirements for a tub to be classified as a hydromassage tub. Without these components, the tub is simply a bathtub with some additional features, such as air jets, but it does not meet the definition of a hydromassage tub. Now, it is important to consider some additional factors related to the installation and operation of hydromassage tubs. The electrical requirements are one of the most critical areas of focus, as hydromassage tubs typically require a dedicated electrical circuit for the pump and heater. The National Electrical Code, NEC, provides detailed guidelines on the wiring, grounding, and overcurrent protection requirements for these installations. It is crucial to consult the NEC and local electrical codes to ensure that the installation is safe and compliant. The NEC mandates the use of a ground fault circuit interrupter, GFCI, for all electrical circuits that supply power to hydromassage tubs. The GFCI is a safety device that detects ground faults, which can occur when electricity leaks from the circuit to ground. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the power and preventing electrical shock. The GFCI is an essential safety feature that protects against potentially fatal electrical hazards. Proper grounding is also crucial for electrical safety. The grounding system provides a path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. A properly grounded hydromassage tub will minimize the risk of electrical shock in the event of a fault. Bonding is another important aspect of electrical safety. Bonding refers to the connection of all metallic parts of the hydromassage tub and its associated equipment to a common grounding point. This ensures that all metallic parts are at the same electrical potential, preventing voltage differences that could create a shock hazard. The NEC specifies the bonding requirements for hydromassage tubs, including the size and type of bonding conductors. Plumbing requirements are another crucial aspect of hydromassage tub installations. The piping system must be properly sized and installed to ensure adequate water flow and prevent leaks. The drain line must be connected to a sanitary sewer or approved disposal system. The water supply lines must be connected to a potable water source. The plumbing connections must be made using approved materials and methods. The use of backflow preventers is often required to prevent contaminated water from flowing back into the potable water supply. Backflow preventers are devices that allow water to flow in only one direction, preventing the reverse flow of water. Maintenance is essential for the longevity and safe operation of hydromassage tubs. Regular cleaning of the tub and the jets will prevent the buildup of dirt, soap scum, and other debris. The filter should be cleaned or replaced regularly to maintain water quality. The pump and other mechanical components should be inspected periodically for signs of wear or damage. Any repairs should be performed by a qualified technician. Water chemistry is also an important consideration. The water in the hydromassage tub should be properly balanced to prevent corrosion, scaling, and the growth of bacteria and algae. The pH, alkalinity, and sanitizer levels should be tested regularly and adjusted as needed. The use of appropriate chemicals, such as chlorine or bromine, will help to maintain water quality and prevent the spread of infection. In summary, a hydromassage tub requires a specific set of components, including a recirculating piping system, a pump, and associated equipment to function as intended. Without these components, the tub is not considered a hydromassage tub. Proper installation, maintenance, and water chemistry are essential for the safe and enjoyable use of hydromassage tubs. Let's delve deeper into the specific components and their functions to provide a more comprehensive understanding. The jets or nozzles are critical for directing the flow of water onto the body. They come in various shapes and sizes, each designed to deliver a different type of massage. Some jets produce a focused high-pressure stream of water, while others create a wider, more diffused flow. The jets may be adjustable, allowing the user to customize the massage intensity and direction. The placement of the jets is also important, as different areas of the body may require different types of massage. Air induction systems are often incorporated into hydromassage tubs to enhance the massage effect. These systems introduce air into the water stream, creating bubbles that add a swirling and effervescent sensation. The air bubbles can also help to exfoliate the skin and promote circulation. The amount of air introduced into the water can be adjusted to customize the massage intensity. Control panels or switches allow the user to control the various functions of the hydromassage tub. These controls may include buttons, dials, or touch screens that allow the user to adjust the pump speed, jet intensity, heater temperature, and other settings. The controls should be easy to use and clearly labeled. Heaters are used to maintain the water at a comfortable temperature. Hydromassage tubs typically use electric heaters, which are thermostatically controlled to maintain a consistent water temperature. The heater should be sized appropriately for the tub's volume to ensure that the water can be heated quickly and efficiently. Filters are used to remove debris and impurities from the water. These may include hair, dirt, and other particulate matter. The filter should be cleaned or replaced regularly to maintain water quality. Different types of filters are available, including cartridge filters, sand filters, and diatomaceous earth filters. Safety devices are essential for protecting against electrical shock and other hazards. Ground fault circuit interrupters, GFCIs, are required for all electrical circuits that supply power to hydromassage tubs. These devices detect ground faults and quickly trip the circuit, cutting off the power and preventing electrical shock. Other safety devices may include high-limit switches, which prevent the water from overheating, and low-water cutoffs, which prevent the pump from running dry. The NEC Article 680 provides specific requirements for swimming pools, fountains, and similar installations, including hydromassage tubs. It covers various aspects of electrical safety, including wiring methods, grounding, bonding, and GFCI protection. The NEC Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and temperature rating. This table is used to determine the appropriate size of conductors for the electrical circuits that supply power to hydromassage tubs. The NEC Section 250.104 outlines the requirements for bonding metal piping systems and other metal parts that are likely to become energized. This section is relevant to hydromassage tubs because it requires the bonding of all metallic parts of the tub and its associated equipment to a common grounding point. The NEC Section 430 covers the requirements for motors, including the motors used in hydromassage tub pumps. This section covers various aspects of motor protection, including overcurrent protection, overload protection, and short-circuit protection. In addition to the NEC local codes and regulations may also apply to hydromassage tub installations. These codes may address issues such as water conservation, accessibility, and noise levels. It is important to consult with local authorities to ensure that the installation complies with all applicable codes and regulations. Proper installation of the piping system is crucial for ensuring adequate water flow and preventing leaks. The pipe should be sized appropriately for the pump's flow rate and the number of jets. The pipe should be installed with proper support to prevent sagging and stress. The connections should be made using approved fittings and methods. The piping system should be tested for leaks before the tub is put into service. Regular cleaning of the tub and the jets will prevent the buildup of dirt, soap scum, and other debris. The tub should be cleaned with a mild detergent and a soft cloth. Abrasive cleaners should be avoided as they can damage the tub's surface. The jets can be cleaned with a small brush or jet cleaner solution. The filter should be cleaned or replaced regularly to maintain water quality. The frequency of cleaning or replacement will depend on the type of filter and the amount of use the tub receives. The pump and other mechanical components should be inspected periodically for signs of wear or damage. The pump's impeller should be checked for cracks or damage. The bearings should be lubricated as needed. Any loose connections should be tightened. Any repairs should be performed by a qualified technician. Water chemistry is a critical aspect of hydromassage tub maintenance. The water should be tested regularly to ensure that the pH, alkalinity, and sanitizer levels are within the recommended ranges. The pH should be maintained between 7.2 and 7.8. The alkalinity should be maintained between 80 and 120 parts per million. The sanitizer level, such as chlorine or bromine, should be maintained at the recommended level. The use of appropriate chemicals will help to prevent corrosion, scaling, and the growth of bacteria and algae. It is important to follow the manufacturer's instructions when using chemicals. The chemicals should be added to the water in the proper order and concentration. Safety precautions should be taken when handling chemicals. In conclusion, a hydromassage tub is a complex system that requires careful design, installation, and maintenance. Understanding the function of each component and following the appropriate codes and regulations will ensure safe and enjoyable use. The absence of a recirculating piping system and pump fundamentally changes the definition of the tub, preventing it from being classified as a hydromassage tub. The presence of an air pump does not compensate for the lack of water circulation. Remember to always prioritize safety and consult with qualified professionals for any electrical or plumbing work related to hydromassage tubs.